Hello and welcome to CEM and Lucidity Systems Wednesday webinars on separation solutions. Today's presentation, Training the Next Generation of Chromatographers Using Lucidity miniGC in the Research and Teaching Laboratories, is presented by Dr. Emanuela Gianfrido of the University of Toledo. Before we get started, let's review some of the features of GoToWebinar. The audio for this presentation is available on your computer only. If you cannot hear the audio, please check your speaker volume. To access handouts for this presentation, click the handouts icon and then click the handout you want to access. The handout file will automatically start downloading from your default web browser. At the end of the presentation, we will have a live question and answer session. You are welcome to submit questions at any time during the presentation. To do this, please type in the questions section and click send to submit your question. Please note that not all questions may be answered live, but they will be answered by email after the webinar concludes. It is now my pleasure to introduce today's presenter. Dr. Emanuela Gianfrido is an assistant professor of chemistry in the Department of Chemistry and Biochemistry at the University of Toledo, and that's in Ohio. Research work in Dr. Gianfrido's lab focuses on developing advanced analytical separation tools for the analysis of complex biological and environmental samples using alternative green extraction methodologies. She received her PhD in analytical chemistry at the University of Calabria. She joined Professor Paulison's group at the University of Waterloo in 2014 as a postdoctoral fellow and manager of the gas chromatography section of the industrially focused analytical research laboratory, and within 3 years became a research associate. Dr. Gianfrido has currently authored over 50 peer-reviewed contributions, including a patent on PTFE-based SPME coatings. Dr. Gianfrido is one of the founding members of the Dr. Nina McClelland Laboratory for Water Chemistry and Environmental Analysis at the University of Toledo, and she is appointed to the Ohio Attorney General's Yost's Environmental Council of Advisors. She also serves as the secretary of the ACS Subdivision on Chromatography and Separations Chemistry. Her research program is currently funded by the National Science Foundation through the 2022 Career Award by the National Oceanic Atmospheric Administration and several industrial partnerships. We are so pleased to have Emanuela here, and Emanuela, over to you.
Thank you, Leanne, for the kind introduction. I'm gonna share my presentation right now. Okay, so today I'd like to share with you all the experience that I had with Lucidity miniGC, not only in my research lab, but also as a good complement to teaching laboratories. My group at the University of Toledo is composed not only by PhD students, but also master students and undergraduate students. So we always want to find the best way to train this new generation of chromatographers in the on the most updated instrumentation and the chromatographic techniques. As you can see in the slide, the miniGC, it's a very compact system that does not require a lot of bench space. And my experience is that I was like amazed how the students were able to install it very easily, following all the instructions that were provided in videos. And like within 1 day from the delivery, it was already operational. So that was a big plus for our lab. Other advantages of the system, beside the easy installation that I just mentioned and the limit bench space requirement, is the software is also very intuitive. So even users that are not used to chromatography, they can be very quickly get used on how to run their sample, how to integrate their peaks and perform calibration curve. One of the features that, in my opinion, is most attractive about this system is the fast column switching and installation. For everybody that had experience with gas chromatographic system, we know that the hardest part of our training as gas chromatographers is to learn how to make the proper connection, how to connect the column to the injector, how to connect the column to the detector. And most of the issue with the chromatographic behavior of our analytes actually results from wrong installation procedures. With the miniGC, we can skip this issue because changing column is just very easy. As you can see in the slide, we have a snap and plug column. And the oven compartment is very easy to be opened. The column can be switched and the system can be brought back to proper temperature very fast. The miniGC, we initially got the miniGC as it is without autosampler, but after a few months, the autosampler was a great addition to our system, and we found out that the installation was extremely easy. And one of the most challenging aspect about installing an autosampler is the alignment with the injector. Well, the miniGC autosampler, it uses a series of magnets that and like very easy instruction that make alignment very doable even by non-expert users. Also, I will show you later on how the reproducibility of the injection it provided extremely satisfactory RSD and almost no retention time shifts. So I'd like to provide now an overview of two projects that we're working on in our lab using the miniGC. The first project is a hybrid between research and teaching. I want to give a little bit of overview about an initiative of the U Toledo Department of Chemistry and Biochemistry. We have an active acetone recycling program that that allows us to drastically minimize the use purchase and cost of disposal of acetone used in our teaching laboratories. So especially organic chemistry laboratories use a lot of acetone for like rinsing and cleaning glassware. In the past, this was a one-way use, like one-time use, and all the acetone needed to be disposed, with cost of over $10,000 per year for our department. So the idea was, if we are able to recycle or recover at least 90% of this acetone via distillation, how much can we save? And also in a green chemistry perspective, how much more environmentally friendly would running our teaching laboratories be? So this initiative consisted in acquiring a distillation unit for acetone recycling that was able to purge our acetone for highly boiling point contaminants. However, once this procedure was put in place, we needed to find a quality control to verify that all the distillation parameters were set in place properly, and all the contaminants that we were targeting were actually lowered in the recycled acetone, so that we can reuse it for more teaching laboratories with no issues. So the project of the purpose of this project and the goal of using the Lucidity miniGC was to identify the major contaminants present in the acetone coming from the teaching laboratories, and also assessing the purity of the sample pre and post distillation. And also, based on the information given by the gas chromatographic analysis, we can actually tweak the distillation condition to improve our recycling process and make our acetone recycling program more efficient. Once these tasks are achieved, we aim to implement the use of the miniGC and the use of standard operating procedure and quality control analysis in the undergraduate chemistry labs. So this will allow not only to give our students more hands-on experience on how to do gas chromatography, but especially using the Lucidity miniGC, we can use the unique feature, especially about the column switching, to teach students how chromatographic selectivity work, how much different in the tension, different type of stationary phase will allow, and so on and so forth. So the first type of column that we use for this project, as you can see, in the slide, we have a snap and plug column that is a wax column. The reason why we chose this type of stationary phase is because the type of contaminants that we predicted to be present in acetone required a quite polar stationary phase. And once we optimize our chromatography, as you can see, even with a very simple chromatographic run, we were able to properly separate our hexanes. We have the main peak of acetone here, and we were able to separate ethyl acetate, methanol, DCM ethanol, chloroform, and toluene. So this gave us quite promising results in terms of what we can or we cannot monitor in this recycled acetone. The chromatogram that I showed in the previous slide was acquired through manual injection. Then once the students were trained on how to perform manual injection in the instrument, we wanted to test the reproducibility of the autosampler. As you can see, once for a series of 15 injection of real samples, the retention time shift was negligible, and we had quite good reproducibility, especially for the early eluters. We wanted to extend the study, so we did more replicate. I believe this was about 25 replicates of the standard sample containing the acetone and the 10 contaminants. And as you can see, the RSD percent for the retention time shift are minimal, and also the RSD for the area of each peak is well within acceptable ranges. So this tells us, yes, the miniGC is a robust system to perform like multiple series of injection over time. Once our chromatography was optimized, we set in place the autosampler. We set in place the autosampler, and we start to run our real samples. We want to monitor how the dirty acetone samples and how the recycled acetone sample will compare with each other. So something that I need to mention about this acetone recycler is that there are different parameters that need to be set up that include the distillation temperature, but also the time of the time window in which the distillation occur. So what we did, we analyzed the dirty sample that you can see here in the red track in the chromatogram, and then we collected distilled samples at different time intervals. What we noticed was that although most of the contamination was reducing after about 1 hour, for some reason in that same system, once the distillation process will last longer, we almost have a pre-concentration of the contaminants that we wanted to get rid of. So this tells us that there were some of the parameters in our distillation units that needed to be optimized. In fact, as you can see here, for the peak that is labeled at about 3.8, that dilutes at about 3.8 minutes, the contamination decrease after 1 hour, but start increasing again after 3 hours and 5 hours. So already this type of experiment gave us a good idea about how the use of the miniGC will be extremely helpful to do quality control on these recycled acetone samples. Before the miniGC came into the picture for this project, we were doing an MR analysis, and that will bring like lot of different challenges compared to a quick and easy GCFD injection. So based on the preliminary results acquired, we went ahead and performed different optimization of the distillation process, setting up different distillation temperature and different collection time. As you can see here, we go from 0.75 hours up to 3.25 hours. And we could actually find out that the best conditions were not the ones that the manufacturer suggested us, meaning using 90 degrees, but actually 80 degrees works best to reduce the amount of these contaminants over time. So all these results that you see in this table, they were acquired doing injection of different sample in the miniGC and integrating the peaks for all the contaminants. Okay, so as I mentioned before, with the wax column that we initially used, it was a 30-meter, a classical 30-meter 0.5 millimeter, 0.25 micrometer stationary phase thickness. Our separation was good. However, we wanted to see if using a different type of stationary phase will allow to improve us the separation factor and the resolution for ethyl acetate and methanol and DCM and ethanol. So after discussion with CM and Lucidity, we acquired, we decided to use a longer column. One of the questions that we had was, okay, will this longer column fit in the conventional holder that we have for the snap and plug columns for the miniGC? And it actually did, as you can see here in the slide. The holder is slightly different, but the column was able to be coiled nicely, and there were no problems with introducing this type of holder in our miniGC oven. So rather than using a wax stationary phase, we decided to use a cyano-based column with 50-meter length, 0.25 millimeter diameter, and 1.4 micrometer stationary phase thickness. In this way, we were hoping to retain better some of the analytes and actually provide good separations for the ethyl acetate and methanol and the DCM and ethanol. The results of this test. Okay, before I show you the results, I just want to show you the chromatographic condition. We just use a split ratio of 15 to 1. and a very simple chromatographic run, nothing too exotic, nothing too complex. And the type of separation we were able to achieve was actually very satisfactory. As you can see, we are changing the type of chemistry of our stationary phase, so the selectivity of our separation has completely changed. So our methanol and ethanol are now eluting before acetone, and they're completely separated. We have to do a little bit more work on optimizing the peak shape for methanol, but that's work in process. And we can have amazing separation for other residual solvents, including hexanes and like hexane isomers. So what's coming soon from this project? We want actually to finalize the chromatographic condition for both the wax and the cyano column, and set up with the miniGC quality control for the target contaminants that that we can detect from in acetone. Considering that we expanded this project not only to the acetone coming from teaching labs, but also to acetone coming from research lab, there were some additional contaminants that we haven't predicted initially, because like in research labs, everything can happen. So we want to create a complementary analysis, a complementary quality control that will allow some targeted contaminant analysis via GCMS. After we optimize our methods, we wanted to understand what's the linear dynamic range for the miniGC is using both columns. So we will run calibration curve in the like concentration range that brackets the average concentration of our contaminants in acetone. And then we will finally be able to establish a quantitative quality control of the recycled samples. All this experience that we are gaining from this project will help us to implement additional teaching modules in laboratories, not only separation chemistry laboratories, but also organic chemistry laboratories, where we can make consideration about how the selectivity of the chromatography change with the chemistry of the stationary phase. And I just show you a quick example. For us chromatographer, that may sound very straightforward and obvious, but I can tell you by experience that for our students, that really lights up light bulb in their brain and give them an advanced understanding of what the chromatographic process is. We don't want to confine chromatography only to the concept, okay, I'm gonna push some button in an instrument, I have no clue what is happening inside. Also with the miniGC, because like the switching of the column is so fast, and the maintenance and troubleshooting is very straightforward, we can work a lot on chromatographic optimization and show our students how different parameters can affect the resolution, selectivity, and separation factor in their chromatographic runs. And finally, we can provide training on how to do quantitative analysis and how to do calibration curves. One of the latest features of the miniGC software is automated quantification, so that will provide an amazing opportunity to show our students how to build calibration curves, not necessarily having to export the data and use Excel. So once this I've wrapped up this first project, I also want to discuss another project that is more like deeply research focused, and this is actually a collaboration with chemical ecology laboratory at the University of Toledo, Professor Apple Lab. So we want to assess how chemical signaling between plants and insects change in response to insect attack. So let me give you a little bit of background about this. Many people may not know that one of the mechanism of interaction between plants is emission of volatile organic compounds that can actually allow plants to communicate between each other and exchange signals. Most of these VOCs are terpenes that can be easily analyzed with gas chromatography. And the composition of this emission actually change at the temporal and spatial scales. So plants are able to distinguish between a harmful vibration that are vibration caused, for example, when insects chew on plants leaves. As you can see here, I have a picture of a caterpillar chewing on the plants, and non-harmful vibration, meaning if you have wind or if you have any random vibration in the environment around the plant. So what was found is that the type of VOCs that are emitted by the plant when an insect is chewing on it are completely different than, for example, when an insect just jumps on it, or when the wind is just blowing through the plant leaves. So what our purpose for this project was, it was to monitor how the composition of the VOC emission will change once caterpillars were attacking our plants. So as you can see here in the slide, we have a list of the most common VOCs that we want to monitor for this project. And in order to provide proper spatial and temporal resolution, we decided to perform pre-concentration of these analytes using solid phase microextraction. So for the one of you that are not familiar with this technique, solid phase microextraction is a type of extraction techniques based on a small amount of extraction phase that simultaneously extract and pre-concentrate analytes. So this type of device can be injected in a GC injector because it has a shape like a syringe needle, and all the analytes can be released into the injector before chromatographic separations. We found, let me move next slide. So for this project with our miniGC, we found that the classical MTX 5% phenyl stationary phase worked best, and we actually achieved satisfactory separation of most of the analytes that we were monitoring for this project. So something that I want to mention about the miniGC is that the design of the injector of the miniGC is very versatile because it allows installation of glass liners that are commercially available. So this allowed us very easily to adapt the injector of the miniGC for SPME injection. So with our miniGC, we do both liquid injection, as we did for the acetone project, but also SPME injection. The advantage of using the SPME fibers for this with the miniGC is that the effect of the pre-concentration that we achieve during the extraction process can actually help bringing down the limit of quantitation that that the instrument can achieve. When we did our optimization of our chromatography for the standards that you see here in the slide, just by injecting the liquid standards, we could achieve limit of quantitation in the like low ppm level, but the preliminary test that we did doing SPME extraction allows us to detect the analytes at medium to low ppb level using the miniGC. So this tells you how versatile this system is for many different applications that you may have for your analytical needs. So the next step in this project, we're building some sampling chambers where we're actually going to put the live plants and the live caterpillars, and we'll allow the interaction between the plant and the caterpillar to take place. And we will sample at different time interval the head space around the plants to see how the profile of volatile emitted by the plant change in response to the caterpillar attack. So these are two very exciting projects that we are looking forward to complete with our miniGC. And in conclusion, I hope I was able to share how the miniGC provide a versatile solution for both research and teaching labs. And again, I want to stress one of the main features is the easy installation and the fast column switching that really brings down maintenance time and speed up analysis, and also the use of the auto sampler that enables high throughput for liquid injection of samples. So this is everything I wanted to share with you, and I thank you all for your attention. And if you have any question, feel free to ask. And Liana, please feel free to take over.
Thank you, Emanuela. All right, we will now begin our question and answer session. I'm sure many of you have questions about the exciting work that Emanuela and her team are doing at the University of Toledo. So I will go ahead and jump in. Just remind you how to ask a question. If you open up the questions pane, you can type in your question and click send, and then we will answer that as soon as we can. And for our question and answer session today, we are joined by Dr. Alicia Stell, who is the product manager for CEM and Lucidity. And so welcome, ladies, and I will jump in with our first question. So the first question is, how easy is it to train students on instrument maintenance and column switching?
Okay, so I can start saying that it's very easy. Of course, students also need to put their focus on it. But I mean, like the instrument maintenance and the column switching is just like a one-step process. It's very easy to show. As I mentioned, within 1 day from arrival, the miniGC was fully operational in my lab. It was very straightforward. I don't know if Alicia has any other insight about it.
Yeah, thank you, Emanuela. The only thing I want to mention, because it gets asked often, is if the column that's installed on that column holder, if it uses standard fittings and ferrules. And the answer to that is yes. So the standard fittings and ferrules that you are used to using, you can still continue to use. So say you were installing a different column, that column holder, it would go the same as you would in a standard GC system, as well as you can trim the column. So some people think that there might be limitations there, but we're not limiting you in that aspect. The way that it is attached to the column holder is how you would normally attach a column to a system.
Okay, very well, thank you both. Our next question is, do the columns for the miniGC provide the same separation efficiency as conventional capillary columns?
I will say yes. From discussion I had with other colleagues, there was kind of perception that the columns for the miniGC will be completely different than the conventional capillary column. I think Alicia can confirm, but I believe that's the same type of capillary columns that we use in the conventional benchtop GCs. So I didn't notice any main difference regarding the separation efficiency compared to the conventional fused silica columns.
Yep, just to add to that, they are indeed the same columns. They're just wound at a tighter diameter. So you need to be wound at an inner diameter of 4 inches or less to fit on that column holder. But the columns themselves are the same ones that you would be ordering. Right now, through ResTech, you can actually order a column wound at that diameter. You just have to add in an extension at the end, and we're working with the other column vendors. I will let you know that the column that Emanuela was using in this presentation was used with a different vendor. So certainly we can get you pretty much any column if you ask Lucidity. And we're hoping to make that so you could just directly order them yourselves as well.
Excellent, thank you. Can the use of the miniGC be implemented in a teaching laboratory, and what are the main advantages of doing so?
Yes, I believe, especially here at my institution, that will be the next step. As I mentioned plenty during the presentation, ease of use is one of the main advantage, but also these type of instruments are very cost effective, and especially for institutions that have like limited resources for teaching laboratories. The miniGC actually provide the opportunity to have a GC system, maybe even multiple GC system in their teaching laboratories at a very convenient, like with very convenient purchasing options, I believe.
Yeah, and to add to that, one of the things that we're really excited about is this idea of the fact that the miniGC is so small and easy to use that it can be placed on a cart, right? So that I think lends itself to teaching laboratories where you can even have this idea of moving it to the students where they need to do and moving to maybe different laboratories within the building. You may be thinking, what are you talking about? We need all of these gases and gas tanks, and that's not going to be very movable. But Lucidity also offers a mini gas system, which is a hydrogen generator as well as high purity air generator. So you don't need any gases. So literally everything fits on a cart very nicely. All you need is standard plugs. So the idea of carting the systems around a laboratory is very possible.
All right, thank you. Our next question is, were the injections done with a liquid sample or by headspace? And if liquid, has any headspace been investigated?
So the injection that I mentioned in the acetone project, they were done via liquid injection. We didn't test headspace, but I don't see any limitation in like using like setting up the proper type of liner and having the proper headspace syringe and do also headspace injections in the miniGC. Regarding the plant volatile project, we directly injected an SPME fiber in the miniGC, so that's considered SPME headspace injection.
Okay, thank you. Our next question, are there any maintenance differences compared to conventional GCs?
To me, the main difference is less maintenance. Like as I mentioned before, once the column is installed on its holder, if you need to change the column, it's just like a one-step process. When you need to change the injector, again, like you have an injector nut that you just need to unscrew, change your liner, and that's also a very straightforward process. I don't see any main difference or any main disadvantage compared to any conventional GC. Alicia, do you have any insight?
Yeah, I would just reiterate that, the reality is that this system has all standard components. So they should be maintained in a very standard way. The difference is that they are together in a very small, easy to use package. But yeah, they're conventional components from the injector to the FID and so forth. So maintenance should be standard. If anything, as Emanuela noted, it's actually easier specifically from that column perspective.
All right, very well, thank you. At this point, we don't have any further questions, so we'll hang on the line for just an extra minute or so, should anyone have a question that they want to go ahead and ask. While I'm waiting, I would like to go ahead and thank Dr. Emanuela Gianfrido and Dr. Alicia Stell for joining us today. Dr. Gianfrido, thank you so much for sharing the exciting work that you guys are doing at University of Toledo. Alicia,
My pleasure.
thank you for sharing with us. It looks like we don't have any further questions coming in. And so this will conclude our presentation. We thank all of you for coming today and for visiting and taking part in our entire webinar series. We look forward to seeing everyone at future presentations. Thank you and goodbye.